What I did was I just set up a couple vectors. Force, displacement. This might be a stress versus strain. I went ahead and put the units in so that, and you can do that with a vector, by the way. As we were working with vectors, you can just, after the matrix, you can just express the units that the matrix is in, millimeters or kilonewtons, thousands of newtons. And you can generate a plot. Let's see how to go about doing this. Right. So you got basically I've defined two vectors. And now I can start plotting these things. Here's the insert, here's the plot tab. Here's the math tab, the default that opens up. Go to the plots tab. Insert the plot. And I have to select a position on the page where I want to insert it. There we go. Insert my plot. You've got a few choices. This one's X, Y. Now all I have to do here is just tell what is, now it's real hard to see. This says X-axis down here. This says Y-axis, which is kind of funny. I think it says X. Let's see if we can expand it a bit. Oops. I'm expanding it, so this says, yeah, this says Y, which is really funny because the convention is, and if I click here, it does say X-axis, and it's really, really tiny, as you can tell. And the convention is conventionally you'd think this would be the Y-axis. It's not. You got to watch out. Okay, one of those gotchas you got to watch out for. And I'm going to shrink it down again. Yeah, I don't know either. There we go. We'll get down to the got to shrink it down to a reasonable size again. There we go. Okay, get a nice reasonable size plot that you like. Just type in, let's see, on the y-axis, what do we want to do? I think it's usually stress versus strain curves. You put the stress on the y-axis. Oops. And the strain on the x-axis, delta. Oops, delta. By the way, got to go back here. Symbols, I've defined delta. Now, for some reason, it's not finding it here. And it might be because I need to grab this and drop it down. There, it found it. As soon as I lowered the graph to lower on the worksheet than my function, than my data, here's my data. As soon as I lowered this graph to lower on the worksheet than my data, it found function f of n and delta of n. I just type my f in here. It picks up that vector. Type my delta in here using this symbol drop-down box here. Put in my delta. Okay, now we can change the types of markers and stuff like that. So we can go line style. I can say none on this graph. It doesn't like that. I think I have to change my symbol first, and then I can go no line. So I can put little circles in, and then I can go no line and take it away. So it doesn't let you do something stupid. If you just go no line first, it will just erase the line. You won't see anything. But if you give it a symbol first and then erase the line, you're okay. All of this stuff is on the plot menu. So you can change the color. Let's give it a line back. Let's make it a dotted line, and I'll change the trace color to red. There we go. And it changed my trace symbol to red also, which I didn't exactly want, but that's one of those buggy things about any program that you run into. Okay, so you can plot two things on the same graph. That's what the next little section is. So this shows D1, D2, So I'm going to add a new plot. Let's see, I put a new plot. I'm going to make it, yeah, I'm going to get rid of the one I just did. There we go. This is the example that's left behind. So I've got time, D1 and D2, and I'm going to make a new plot. Insert new plot, put it right about there just to make sure we have some time. I don't know why it put it there. Make sure that it's below the data and there we go. So make my new plot, put in time for the, remember, let's see, time for the x-axis. Is that right? No, I want to put in time, yeah, time I think needs to be on the x-axis. Why did I put it on the y-axis over here? Let's do it differently. Always good to experiment. So I did it this way over here. Gee, let's do it this way here. And D1. And just click anywhere, and it gives me my nice plot. You'll notice a difference. I switched the x and y axes between this plot and this plot. I switched the x and y axes. So I can give it a symbol. Just like before, I could use an X for this one, for example, and give it a different color. I'll leave it blue. Get rid of the line. There we go. Now, add trace. There's your key right there. You want to put more data on this thing. I add trace on the y-axis. Type in D2, the data that I've defined. Click. I get a second trace. There's your second trace. And now I can click on this, change my trace, give it a trace symbol. We'll make that open circles, and a trace color black. The default's black. I'm fine with that. Get rid of the line, and voila, we have this. So this is how you add a second trace, just right there. You can change your plot type. So you have lots of different types of options you have. You can delete the trace. So I just delete it. There we go. It goes away. I do a Control-Z, undo. It puts it back. Okay. So now I'm not going to get into the 3D plotting so much. This example, by the way, I'm showing you the examples from the book. So when you read the book, you can see the examples. This one's really trivial, really easy. X, for the x-axis, I just put X. I just put a function over here. I could have made it a cosine X. Let's show that. In fact, let me just delete this all the way. So you can type in a function there. Click. Now it's the cosine function.
So you change your x on the bottom, or your independent variable, and make it do something different?
As in, oh, well, let's try this. I don't think so. We'll find out in just a second. Ooh, you can. You can. Now, this, cosine versus sine, you expect to get a circle. Now, you can change the scale. Well, the y-axis scale is from -1 to 1. The x-axis scale, just click here, and we can make this 1. And it'll change the scale for us. And I click here and delete this one and click outside. Now it's rescaling it. And, ooh, I want to click, boy, the sine x is going from -1 to 1. You can do the same thing on the y-axis, force it.
I guess it was doing it by itself.
Yeah, I think you're right.
Since you didn't specify on
Right. There we go. And you're right. It only does a certain amount. Yeah, the best thing to do would be to define a vector x and then plot sine versus cosine. So this gives us a little experimentation how to make things work right in MATLAB. Okay, there is a book example of this. This is a function I've defined, and this is a formula I've defined. So this function's hairy. That's why I did it before class, basically. Um, you can integrate in MATLAB. There's your integral symbol. Go back to math. Click operators. Um, there's calculus, the prime operator, integral operator. So you do have calculus operators available to you. I would suggest you do this example on your own, this book example, uh, just for practice. I'm going to move this out of the way. There we go. Just to make sure the formula, yeah. So here's the formula, and I didn't want this to interfere with the formula. Okay, and this is a formula too. So a fraction divided by a fraction divided by a fraction. Anyway, it's ringing. Basically, it's the harmonic oscillator with damping, with friction involved. And time on this axis, uh, t is up here. It's the variable of the function, x of t. And of course, x of t is right here. Okay, so chapter 15 was on functions. Excuse me, plotting. Chapter 15 was on plotting, chapter 15 of the Seamer's book. And I just wanted to show you a few things about that. This is about as far as I want us to get in Seamer's. Mostly, once you get this far, you've kind of got an introduction to what it's all about. And you can do some useful things. You can create functions. You can make vectors and matrices. You can plot.
I feel like this is why would you not use Mathcad? What's the purpose of this instead of Mathcad? Instead of MATLAB? Huh? Instead of MATLAB? MATLAB.
Well, okay, the main purpose is UT Tyler uses it in your more advanced courses. Both MATLAB and Mathcad, they use both of those in your more advanced courses. So that's why we give you a little introduction to Mathcad, Mathcad Lite. Just want to get you started, kind of how it works. And then MATLAB, MATLAB is used more, but in your more advanced courses, your capstone projects and the like, you will be using this stuff. And of course, the double E's go more on to C++, which is why people going into double E are doing independent C++ projects. Yeah.
I want to talk about something else, but whenever you're done.
Okay, right. I'm about ready to wrap up unless there's any class questions. No.
There is a class question. When it comes to the final, you said something about our test grades replacing our final grade if our test grades were higher.
Whichever one's higher. If you do better on the finals, then that'll be your test exam grades. If you do better on the exams, then that'll be your exam grades. So basically, I'm giving you a break. Know your stuff coming into the final, and you can make up for any past problems you've had. Right. Also, on Friday, I will be sure and go through the math problem that I will be posing so that that doesn't trip you up. So you'll know. You will need to do the Excel and the MATLAB exam.
Right.
The Mathcad stuff you won't need. Right. That's correct. Basically, the people doing projects, that portion of the final won't count. Your project grade will substitute for that portion of the final. Okay. No more class questions. I can run around for individual questions then.